All right, it shouldn't be that big of a deal. Today, again, we're just doing, for the most part, area of a circle, which, like I said, don't feel bad because my fifth graders were taught how to find the area of the circle, except they use 3.14 for pi, and we leave it in terms of pi. All right, we leave it in terms of pi. So today, if you don't recall, the formula for area of a circle was pi r squared. So let's just finish this off real quick. If the radius is 5, the area would be what?
25 pi.
10 pi.
25 pi.
10 Wow,
25 pi inches squared.
It's a birthday small, let it go.
25 pi inches squared. All right, so question number 2, the area would be
Dang, you're smart.
Did he ask you?
100 meters squared times pi.
Yeah, no, I said it right. Man.
9.5 squared pi.
90.25. Whoa.
So 90.25 pi inches
Are
squared.
you sure about
All right. Boys, enough now, all right? Can we just get through the lesson without the sarcasm? First thing on Monday. So, number 7. Here we go. It says the area is 153.9 square centimeters. All right? So, if you have the area and you need to figure out what the diameter is, of course, 153.9 is equal to pi r squared. So, first thing you do is divide by pi. And what does that come out to be?
48.987.
48.987. So the radius is probably what? The radius is 7. And so if the radius is 7, the diameter would be
14.
14. All right. Any questions or concerns? All right. All right, so let's do number 10. Everybody do number 10 and tell me what the radius is this time.
It looks like it's 8.
Anybody agree with that?
Yeah. If you round the 60 to 1/6
I don't. For number 10,
Yeah,
I don't think it's 8.
I got 5.639.
So you have to divide by pi first.
So it's 20.2.
It's 63.6 divided by pi.
Equals, and then you take the
Square root.
square root.
4, 9.
What is it?
4.49.
So 4.599. Is that what you said?
4.9. Just do 4.5.
All right. So thank you. About 4.5 what? Feet. All right. Just make sure you put the proper units. All right. Area is measuring in squares. Length is in units. Okay. Now, here is something that I'm not sure why a lot of people find difficult. So listen carefully. This is called the area of a sector. Look up, please. That's the area of a sector. All right. So I understand it's just a fractional part of the area, correct?
Oh, it's you do like 36.
What fraction is it? What is it?
1/10.
Yeah, 1/10. But if you didn't see it was 1/10,
36 over.
so you would say it's 36 parts out of what? 360. Come on now. Like I said, I don't understand the confusion here. All right. A sector is simply a piece of the circle. All right. So the formula is the area is equal to pi r squared. That would be the whole circle. But we only want what? A part of it. We want what part? We want n parts out of what?
360.
Out of 360. That's the general formula for area of a sector. All right? So all we're doing is we're saying A equals pi times 5 squared times 36 out of 360. Now again, leave it in terms of pi. So it'd be what?
1 over 10 times 25.
That's what I'm interested in.
2.5.
Or area equals, if you want 2.5 pi square inches, or you just could have said 5/2 pi inches squared. Normally, believe it or not, it's the fraction. All right? Normally, it's the fraction. All right? I don't care if you leave it as a decimal, but trust me, next year, you'll always be working with fractions and not decimals. All right? So, leave it as a fraction. All right, just to show you again how simple it is, let's take a look at number 1.
So pi r squared times 45 over 360. That's 3 squared to 9.
Yep. So all you're doing is you're thinking that, and here's something I want to tell you guys too right now. Think about it for a second. Pi times 3 squared. Can anybody tell me 45 degrees is what part of the circle? I need you to know that. All right, because thank you. That's exactly how you should be thinking of it. 90 degrees is 1/4, right? So 45 is half of 90, so half of a fourth is a what? Is an eighth. All right, so it's simply times 1/8. That's how I wish you would think about it. All right, so now we can say our answer is simply what?
1.1242.
9 pi over 8 square feet.
Oh, that's
All right. Now, just practicing some mental math, guys, because some of you need practice. All right, please pay attention. All right. I want you to tell me what would be 15 degrees. What fraction of the circle is 15 degrees?
16.
So what is 45 degrees?
And 8.
1/8.
A
A third of that.
124.
1/24. You should be able to tell me that. All right. Listen now. Again, I'm not trying to say, well, that's so obvious. All right. I'm not trying to say you should just intuitively know that. That's not the point I'm making. The point I'm making is we just said 45 degrees is what?
1/8.
1/8. And I'm asking you about 15 degrees. So I'd like you to say that 15 degrees is what? 1/3 of 45. So then 1/3 of 1/8.
124.
Let them think about it. And so it doesn't matter if you say something ridiculous. That's part of the problem some of you have. You don't want to sound ridiculous, so you don't say anything. All right, get over that. It doesn't matter. All right? Just for once, say something on your own. That's what I always say. Don't listen to anybody else. Think for yourself. All right? I'd like to hear from somebody else besides the same 3 people that answer all the time. All right, you take a chance. So again, the answer would be what? What fraction is 15 degrees? 1/24. It would be 1/24 of what?
20 squared pi.
Good. So the area would be 20 squared times pi. All right. Now, let's get to, without using a calculator, we're trying to reduce.
400 over 7.
I know, I'm agreeing with you. But I'm saying I'd like you to do the mental math on 20 squared divided by 24. So instead of doing the 20 times 20 is 400 and then reducing, you're trying to reduce it, all right? Try reducing it in your head. You don't need a calculator to reduce that. That's what you're practicing right now.
100 over 7.
So right now, I would see with you that there's 2's in 10, right? I mean, 2's in 20. So I could make that 10 times 10, and that would be 6. Oh, I'm sorry. I'm sorry. Well, no, actually, I'm right. Because I'm dividing 20 by 2 and 20 by 2. I'm dividing by 2 2's. Right? So essentially I'm dividing by 4. All right? Now what? There's another 2 involved, correct?
50.
Yes, so 2 can go
So we could say that that is a what? 3 and 5. So there you have it. 50 pi over 3. 50 pi over 3. All right. Yes, and of course, the calculator is 20 squared divided by 24, math, enter. I'm not arguing with you about that. All right, of course, I want you to know that's available. All right, but I also know some of your ERBs, you're not going to have your calculators, and so your mental math, it's nice to be kind of sharp with your mental math. All right, you don't need a calculator for basic fractions. All right, so let's take a look at this problem right here.
It's 1/10. No,
It's
30.
9
They're not
tenths.
looking for 30. No, I'm saying
Right.
36
So
is
it's
1/10.
36 is 1/10, so
But then
we're
you have to
looking
subtract
for
it. You have to
what?
subtract it.
There you go, guys. All right, so now it's going to be 10 squared times pi times what?
9 tenths.
9/10. So now you're expected to do the math mentally. So again, of course, we would just divide out a 10, right? We're not going 10 squared and then dividing by 10, right? That's exactly correct. 90 pi. All right, 90 pi.
It's 90.
Yes, 90 pi. Think about it. Come on. All right. All right, let me see what else. So,
Wait, what did you divide out?
just there was a common 10, right?
A common
10 and 10,
0. Okay.
right? So instead of doing 10 squared and dividing by 10, we just said it's 10. All right. And then, so if that's 20 degrees, we're looking for what?
340.
Now, to me, 340 would be okay, but to me, 20 out of 360 would be easier because that would be what? 1/18th, right? Everybody with me on that? So that represents 1/18th.
17/18.
So now you need what? 17/18. So you need 17/18 times 7 squared pi. Now, does anything reduce on that?
No.
No. All right. So now you'd have to say 49 times 17 divided by, now, and I wouldn't even divide it by 18. I would just, somebody tell me what 49 times 17 is.
833.
And then 833 over 18 pi, and that would be meters squared. All right, that would be meters squared. All right. So, you can't. Now, how do I know? Again, this is something else I'd like to just review with you. All right, why do I know I can't reduce the 7 squared times 17 and the 18?
Because they're both front, or they're both
17.
whatever.
Okay, but it really, honestly, it doesn't, you're correct, they're prime. But it doesn't mean just because they're prime, they can't be reduced. There are prime numbers that can be reduced. Like 7, is prime, but that goes into 56. All right? So, again, how do I know I'm not going to be reducing?
There's no common.
There you go. Common factor.
Greatest common factor.
Yes. So with 7 squared and 17 and 18, there's no common factor. Because if there was a common factor, it would have been easier to do what first? Reduce it first. All right? That's what I'm trying to show you. All right? So again, the mental math is a super important in order to be better at advanced math. It's amazing how many kids I sit down with and ask about fractions and they're taking calculus. Well, I don't know how that's possible. That's part of the reason why they have so much trouble. All right? And that's what I'm trying to tell some of you guys right now. You're good at math now. All right? But if you're not great at the basics, advanced is harder. All right? I have no doubt that the concepts you can understand. But the math, when you're dealing with fractions, for whatever reason, sometimes there's a problem. All right? So that's why I want to answer any questions right now. If you're not sure what I'm saying or how I'm reducing things in my head, it would be good for you to ask. All right. Now let's just go down here. Let's look at number 7. Let's see what that says. So all they're doing is saying,
So each length is 2.5.
On the area of a third.
yes, that's what you're supposed to be telling me. Yes, the degree measure would be 120 degrees. All right.
2.5 squared times 1/5.
Yes, exactly correct. 2.5 squared, which is 6.25 over 3 pi inches squared. All right. You should know 25 squared is 625. All right, then just put the decimal in the right spot. Now the reason why I just went ahead and divided by 3 again for the same principle as I did before. 5 squared and 3 do not have any common factors. Therefore, I know I'm not going to be able to reduce the fraction. Thank you. Go ahead.
Is it 6.25 pi or 6.25 meters?
There's a pi involved, right?
Is it any like the 6.?
Okay, so again, does it matter? You with me on that? You see why it doesn't matter, right? Because it's pi over 1. So you could write it as 6.25 pi all over 3. Or you could just say 6.25 over 3 pi. All right? Yes, you're multiplying. All right, the only thing is it doesn't go in the denominator. Yes, sir.
I know you showed us the trick for multiplying by 11. Is there any like tricks for the higher number to square?
Yeah, so in my opinion, that's why fractions are so easy. Like if you say, for example, 4.5 squared, that, well, to me, if you do 4.5 squared, here's how I do it. I think of it as a fraction 9 over 2. And then when I square, it's 81 over 4, which is 20.25. It's very easy. And people think, oh my gosh, you're so good at it. It has nothing to do with that. It's the fact that you're putting it into numbers that are easier. That's why I tell people fractions are much easier to work with, because you can work with individual numbers, right? When someone says 4.5 squared, it's just not that easy, all right? And as far as, different types of multiplication, there are, like if you see those commercials where the guy's multiplying a bunch of digits in his head or whatever, they're special numbers, right? And there are special combinations that work specifically for those. And what they've done is they've memorized the patterns to the numbers, right? I looked into it, but it's okay to do that,
Too hard.
but it's almost like memorizing the digits of pi.
You're not.
It's
You're
what
not
I mean?
understanding it.
Yeah, right.
Like if you can just plug it in here.
That's exactly right. So what I'm saying is this. What I'm saying is that it's like multiplying by 11. There's just little weird things that work out. And again, the only reason I remember that is because I multiply by 11 frequently. But to me, knowing how to do 4.5 squared is more important, because there's no trick to it. It's just converting it into a fraction and squaring them individually. Yes, and then putting it back to decimal, because who can't divide by 4, right? Divided by 2 twice. All right. So, did I put the answers at the bottom?
Yeah.
Random.
I don't know what happened.
Those are the answers to the
No, that's just
Yeah, this one is.
plugging it in.
Hold on. Yeah, these right here. That was the solution to the study guide, is what I think I did. All right. So here, the homework. The only thing I really need you to do is the skills. No, actually, look, pay attention, please, because the ERBs are coming up. All right. And again, I just like to say how great you guys are doing. All right. So that's why I want to include these. All right, so everybody do 11.3 to practice, which is kind of easy. And then go down and do the word problems. All right.